So today we're going to be talking about interprocess communication, and I'm going to be talking about a way to do that in LabVIEW that's simple and effective, both in performance and design, and I'll be showing how to use user events to create public events to your modules or components, objects, actors, or whatever you prefer to call them in LabVIEW. So let's talk about that. So this presentation is similar to one that was given at the 2011 CLA Summit by Justin Gores, and then also at the NI Week 2011. And Justin talked about public and private events and showed a class template or a library template for doing that. And I decided to de-scope that a little bit and just focus on the user events, public user events for a module, and not get into the implementation of how you do the plumbing inside of a component, but actually to show how the public events interface is useful for interprocess communication between two components that need to talk to each other, or one that wants to receive events from the other. So the scenario here is that you have an active object that has a process, which is basically a loop that's doing things asynchronously and generating or producing data associated with those events. And you have one or more processes that need to make synchronous calls into the active object, know when an event happens, get and consume the associated event data. So today I mentioned I'm going to be talking about public events, which really addresses this bottom use case of knowing when an event happens in an asynchronous object, and to be able to consume the associated event data. The reason why I left this out is there's a variety of different ways to do that, different types of mechanisms that'll be most effective based on the type of communication that you want to do, whether it's synchronous, asynchronous, whether it can be lossy or not, all those things that Chris mentioned, all the forms of messaging. And so I wanted to really just kind of talk about public events as a way of extending one's framework. So here we go. So first off, I really like user events. I think they're a very easy to use feature with a lot of functionality. And when they were first introduced, I just thought to myself, wow, this is like a really awesome native LabVIEW feature. And it seemed to me that new features kept coming out related to the event structure. And it seemed like piggybacking on that feature as a fundamental form of object communication, it seemed like the way to go because they'd keep adding features to the event structure and it would make it even better over time, make the frameworks even more full-featured over time. So this really forms the basis of a lot of JKI's internal application frameworks and templates. We use it a lot for a lot of applications, big applications, and we've had a lot of luck with it. There are some caveats we'll get to, which I mentioned. Basically, we ran into some stumbling blocks over the years. Things have definitely gotten better, and we'll go over kind of a list of those and when they happened. And again, we mentioned, Steen mentioned the timeout issue and how that got resolved as a result of the CLA Summit. So I like to, as quickly as possible, get to code in my presentations, and I should have done it quicker, so let's see some code. So just to set the stage here, this is basically a VI tree and a library showing a public API of a component. And this could be a class, this happens to be a library. These are public VIs that are meant to be called by users. The one that's not actually showing up here is the get public events, which is this guy. And you can see that there's some private stuff like a process that will run asynchronously. And then here we're seeing the VI tree. So I'm going to be basically talking, just imagine your own component template, whether it's an actor or by reference object or something. You'll be able to use this technique. So the idea is we have a VI that we add to your component called get public events. And this VI outputs a cluster of user events. And this cluster gets wired into an event registration register events terminal that can be wired into an event structure. And using it is really easy. It turns out that the register for events, as you guys probably know, accepts a cluster as an input, and it will just sort of automatically sort of flatten all the cluster elements and make the user events available in the event structure. How many people are using dynamic user events in their frameworks? Okay, so I'm preaching to the choir here. And so you probably already know some of this stuff. Hopefully this sets the stage for some of the subsequent presentations by Fabiola and Jack. One of the things that I really like about this, which Chris was mentioning as being important, is ease of debugging and accessibility for users. I've seen a lot of frameworks, and I've worked with people with some really advanced and capable frameworks. One of the things that I really like about this feature as an aspect of one's framework is that it really makes it easy for end users. You can wire in the get public events into the event registration, wire this into an event structure, and then just pop up on here, and immediately you have all of the events and event data. There's no need for calling special VIs for converting variants into the type of the message and enums and things like that. It's really straightforward and simple. So again, get public events, register for events, and you handle them. So the idea here is that the framework dynamically spawns an asynchronous process, which is a while loop. I've seen some frameworks where people actually just drop statically a VI that just runs continuously up in an upper loop. Your framework, your asynchronous actor, is then firing events which then get caught by this user's loop. The code maintenance is really easy. One of the things that I absolutely love about this framework is that if a developer wants to add new events to this cluster, they can just edit the type definition, drop a new user event into the cluster, and again, automatically the end user just needs to pop up on the event structure, and it immediately appears in the list of events that they can choose from. Similarly, if we have an existing event that has a cluster of event data inside of it, and we add a new element or we change a data type of the element, that new event data automatically appears in the list of data that the user can choose from. And so there's really not a lot of heavy lifting to convert. For example, if you're sending flattened data or variant data, doing the type conversions for end users. And I've seen implementations based on queues and things like that, and it's always seemed like there was a lot of extra bloat on the template. Using the event structure makes that easier. One really cool thing about this design is that this is essentially a publish subscribe. The active object is essentially has a list of events that it's publishing, and you can have multiple consumers or subscribers to those events. The event registration terminal is actually subscribe me to your events, and then the event structure is actually the DQ or the handler of the event. And so the way that you would do that is you would wire the public event references into an event registration for each parallel loop that wants to receive those asynchronous events. So the one thing you have to be careful of here, though, is, as you guys know, and I'm going to walk through a list of caveats here, you should never fork the event registration, because this is essentially one subscription to the events. And so if you fork the subscription, then it's like your neighbor coming over to your porch and stealing your newspaper. Hopefully you get that analogy. It doesn't work out well.
Well, I guess it works if you're just reading it and putting it back. Because the thing with forking the wire is you might or might not get it. That's the problem.
You might or you might not, and then this guy might get it and that might not. It's
never who's going to get it. So the analogy works as long as he puts the newspaper back.
So it does. So really what you need to do is you need to call the register for events for each event structure that you have. And so again, this is more like what you want to do. But in reality, it's okay to actually just call get public events, because this is just returning some handles to the events. And while this may seem a little bit redundant in the code, it's actually more modular way to do it, because you can, if you wanted to, wrap all of this in a sub-VI or something. So again, this is a very simple example of something users could do to subscribe to the asynchronous events that are generated by an active object. I wanted to talk about how you would integrate this into a state machine because there are more gotchas. And the reason why I'm mentioning these two is over the years, as we've been using this, we've hit these gotchas, and they've caused a variety of issues, some of which we've fed back to NI, and they've made them better. So the first gotcha to be aware of is around event type propagation. So in order for the kind of the automagic stuff to happen, where when new event types and data changes occur, at edit time, the type propagation needs to flow freely from the event registration into the dynamic events terminal. And if you type def, or you put this in a sub-VI, then all of a sudden the typing information doesn't flow freely at edit time. You have a control in the way, or a type definition in the way, and that type definition needs to be manually edited each time you change your event types. It'd be great if there were a control in LabVIEW that were typeless, that could automatically propagate type through it at edit time, but we'll have to wait for that. So when you use this inside of a state machine, it's very useful because you may want to dynamically register, and sometimes you may even want to re-register, like unregister, re-register, change registrations if you have multiple events that you're registering for. And so putting it in a loop is pretty helpful. So I designed a very simple state machine that has an init, a run, and a close frame, and I'll just walk through each of these. So in the init, you'll want to register for events. In the run, you'll receive event data. And then in the close, you'll want to destroy the event registration and shut down your actor.
Jim?
Yeah?
Why do you wire the wire back out of the close? Why not just make that not a red one?
Well, so you probably could have. The reason why I didn't write here is because I was going quickly, kind of building up my presentation slides. And then also, too, it may, probably not, but it may affect the type propagation. It may add some potential confusion to the type propagation algorithm. Probably not. That's a good point.
I was just curious.
And there's one more bug in my code you may have seen, which I'll get to. So in the two-state machine mode, what you'll want to do is you'll want to move the initialization and the closing outside of the loop, because each of these loops is essentially subscribed to the active object that is initialized out here. So you don't want to initialize, in this case I've got a singleton, there's no reference to my component. If I had a reference and I were storing that in each loop, then I would have two actors, but in this case, because it's a singleton, there's only one, so I need to initialize and close it outside of the state machines. So okay, now the gotchas for doing it in the state machine mode. In the initialization, you don't want to wire this input. The code should work correctly, but in terms of at runtime, the problem here is that if you wire the input, when you start to change the event registration, it won't propagate type out the right-hand side. This register for events is sort of an overloaded node. It serves both as a re-registration or change registration and a create registration. If you don't wire the input, then it's a create event registration. If you wire the input, it's a change or create if it's a null ref num or invalid ref num. And so what will happen here is if you wire the input, as you change this, your output type won't change because the input type is defined as what it used to be. And so it makes it so that the user's state machine will break every time the developer of this component changes the public events. So you don't want to wire that. The other thing too, you want to make sure to give the event registration its own shift register. The moment you start bundling it with other state data, it can add some snafus to the edit time type propagation. And then the other thing you want to make sure here is you don't want to wire this through. There's actually another little gotcha that got me when I was doing this. I was showing the presentation to Philippe yesterday, and he's like, I think we do it the other way. And I can't remember exactly why we did this, but I remember there was a bug a while back, which when we were wiring out of the right-hand terminal up into here, it either caused some problem with the type propagation, or sometimes, or maybe it was a runtime propagation of the reference or something like that, but it didn't work quite right. And one of the reasons why this gotcha got me is because basically we've implemented this style of state machine with event handler into our framework template, and so I never have to code this. It's been coded once and I just copy the template. My other excuse is I don't do as much LabVIEW code as I would like to these days. And when I do, I use a template. And that's why I barely passed a multiple choice CLA exam. Yeah. Just so I could come here. So kind of getting towards the summary here. Basically, the benefits of this public events approach for this publish, subscribe style of messaging is I think it really saves a lot of time for module developers and module users. There's not a lot of support functions for each type of message that you'll want to pass out. When you add new types of messages that you want to publish, your users just get them for free in their event structure. They don't have to call your support VIs or tweak their code. And I personally believe that this really improves performance of applications versus polling for data. In our applications, we'll create public events for like data changed, like motor position or motor enabled, and we'll have a user interface that's displaying the latest state data, and the user interface is just all update immediately anytime any status information changes in the application, and for very, very large applications too. Versus older versions of those applications that had to pull for data before the event structure. As we started scaling up, all those parallel loops running at 10 milliseconds or whatever were just really bogging the machine down. With this architecture, everything is really event driven. You have all these user interfaces open, but none of them are actually running until some event changes, and then everybody updates all at once. It's pretty cool. I also think coding in this way with essentially by reference subsystems that have public events can improve the design of applications, especially large applications, by loosely coupling producers from consumers. The consumers of these events, the subscribers, don't really couple in any way, create coupling to the producers. The producers don't know that there are consumers. They don't know how many there are. They don't know what they're doing with the data. And the consumers really don't in any way affect the producers. The one caveat to that is that because of the way the event structure works, when an event is fired on the event data terminal, you can get the user event reference out, which basically means that any consumer actually has the event reference and could fire the event. And I haven't found a way to basically privatize the firing of the event. And so that's one area where potentially the encapsulation could be violated by a consumer that chooses to get that event reference and inject events, essentially spoofing the active object. But we trust our users. The other thing too is, what's that?
Famous last words.
Yeah, I shouldn't have told you guys. Now you can't be trusted. Nobody leaves this room. It's also extensible. I think that this design pattern of adding public events to modules is really extensible and can be compatible with all kinds of different by reference and by value architectures. I'd be curious to see if people are already using something like this with the actor framework. Maybe we'll see people showing stuff later today. So in terms of extensions and tweaks that you can make, obviously incorporate it into your module template by value, by reference, actors. Starting and stopping the asynchronous processes, I didn't want to go into this at all because there's a lot of different ways to do it. Here shows one object reference being dynamically run, started asynchronously. There's some handshaking that you're going to need to do to make sure that the process is started correctly, especially if the process itself is registering for events in your objects. You want to make sure that when you call initialize and it's starting up processes, that before your initialization function returns to its caller, that all the processes have started up correctly. You can also have private protected community events, essentially by scoping your get events function. You can actually have a get private events, get protected events, get community events. We use private events a lot in our objects at JKI. And also sending messages into the asynchronous process. So an active object may have like a VI called acquire data that doesn't actually return any data. But you want to make sure that, you know, when you call that function, that it messages into the active object and it starts acquiring, and you want to get a handshake back from your object that says, okay, I started acquiring. And so how you would implement that handshaking into your asynchronous process is basically left for the audience to figure out themselves. There's a lot of different ways to do it, queues, notifiers, and things like that. Okay, so this is an interesting deck, and I basically copied this from Justin's slide. And it used to say things that suck. Now it says things that sucked because a lot of them got fixed. The most annoying bug ever was the event structure frame remapping. Basically what happened was at some point when your event registration got broken and then it got fixed again, or sometimes when you added new events or removed them, frames of the event structure would just switch and be associated with other events. And so our workaround for that was obviously source code control, and then also just putting labels inside of each event frame that said what it was really supposed to be connected to. And that got fixed in 2011, and we were extremely happy about that, as were our customers. The event structure timeout gets reset whenever unhandled events fired, and that was really cool when we realized what was happening. And essentially with this problem, the result was that the loop would never execute because it would never, your event structure would never time out, and so it could never iterate again to handle events that were occurring less quickly than the events that you were never handled. Essentially with this framework, the way that it works is the event registration is registering for all of the events that the active object is producing. But then when that registration goes into the event structure, the handler, it's at that point in time when LabVIEW under the hood does a little housekeeping and says, aha, this event structure actually is not handling certain events that were registered for. You know, nobody's going to go pick up that newspaper. Therefore, they recycled it. And so now basically those unhandled events don't reset the timeout, which seemed most intuitive for most users, and that was fixed in 2012. No event queue management in introspection. One of the challenges that we've had is when certain events that are handled by the event structures are generated extremely fast, and the event structure actually can't keep up with how quickly they're being produced, like maybe a mouse move where there's an event that occurs every time, you know, a pixel move occurs. Essentially, we get what looked like memory leaks. And so maybe that's fixed in 2013, or maybe there's some tools there. Also, no notifier-like behavior for those situations where maybe you don't actually care about every event that occurred, like a mouse move. You just kind of want to know, okay, well, when I have time to process it, I want to know where is the mouse right now, not where was it the last 1,000 pixels. So the ability to ignore previous, or essentially flush everything in that queue except for the latest one. So we'll see what comes out in 2013. So again, the take-home points here, user events, they're really easy to use. They've got a lot of cool functionality, and it really feels like a good way of doing events for active objects and components in an application. And as the event structure and user events get more features, obviously your end users of your framework are going to get those features for free. We've used them at JKI extensively, and they've really helped us out in our coding. And I really hope to see more features added to the event structure in the future. Things keep getting better, and we're very thankful for that. So finally, our marketing department asked me to put this slide up. We're still hiring, and we have a very international team, people from France, Finland, Guatemala, Canada, French Canada. And so we love international folks, so feel free to get in touch with us. And that's it. Thank you very much.